An exponential function of the form f of x equals a times b to the x that passes through the points 2, 2, and 4, 1/2. First question, what is the equation of the function? Well, I'm going to begin by trying to look at a table of values for this function. So I'm going to jot down what I know. There's x and there's y values, and I'll start with 0, 1, 2, 3, 4. I know that the second term produces 2, right? When x is 2, y is 2. The other thing I know is that when x is 4, y is 1/2. So, I also know that it's exponential. So as I move forward, I have to multiply to move forward. Well, if I'm going from the number 2 to 1/2 in 2 jumps, I'm pretty sure what I'm multiplying by is 1/2. Now, there are other ways I could figure that out. Yeah, in fact, I'm going to show you one. But I think intuitively, I believe my multiplier is the number 1/2. What we've been looking at in class is, considering this function y equals ab to the x, and then write two equations based on the points we have. So, for example, when you look at one of the equations, I've got y is a 2 and x is a 2. And I also have another point where the y is 1/2 and the x is 4. So if I plug those carefully into the equations of this form, I end up with the following two equations. I get 2 equals ab to the second power, and I also get 1/2, that's the y, equals ab to the fourth power. So this is kind of the system of equations approach to figuring out what a and b are. So I guess I probably would get a alone in one of these equations. So I'm going to get a alone in this first equation. To do that, I'm going to divide both sides by b squared. So I get 2 divided by b squared is what a equals. And the other thing that I get, now that I have this value of a, this is equivalent to a, I'm going to plug this into the second equation. So when I make this substitution, right, I'm using the substitution method, I end up getting 1/2 equals, now instead of a, I'm going to write 2 divided by b squared, and I'm multiplying that by b to the fourth power. And there's an implied denominator of 1 here if it helps you look at this. Now, just to clean this up a bit, I might write this as 2b to the fourth over b squared. And if I look at that, b to the fourth power over b to the second power, that's exactly equal to b squared. So I have here 1/2 equals 2 times b squared. To get b alone, I'm going to divide both sides by 2. Turns out 1/2 divided by 2 is a fourth. So this gives me 1/4 equals b squared. And if I take the square root of that, there's two values I get. I either get positive 1/2 or negative 1/2. In this particular setting, I want the positive root. So b is 1/2. That's my multiplier. And again, I saw this early on because if I'm looking at 2 and I multiply that by 1/2, 2 times 1/2 is 1, and 1 times 1/2 is 1/2. So yeah, my multiplier is definitely the number 1/2. Now to figure out my 0th term, right, I can do it one of two ways. I can look at this table and say, hey, to move forward, you're multiplying by 1/2. To move backwards, you can either divide by 1/2, which is the same as multiplying by 2. So this should be a 4, and then this value right here should be an 8. So now I see my 0th term, right? I'm going 8, half of that is 4, 4, half of that is 2, 2, half of that is 1, 1, half of that is 1/2. So I do see my 0th term, and I also see my multiplier. Another way I could get that is, now that I know over here b is 1/2, I could take either one of my equations, actually probably this equation, right? This equation said what a was. And if I take this value, this equation that tells me what a value of a is, it just says, oh, a is going to equal 2 divided by b squared. Okay, so that's what a is. Well, 1/2 squared is a 4, so this is 2 divided by 1/4. And if I'm dividing by a fraction, dividing by a rational number, I would invert and multiply. So this is 2 times 4/1, which is the number 8. So a is 8. So we see it both in our table of values over here that a had to be 8, and we also see it here by just using this substitution technique. So now that I know both my 0th term 8 and my multiplier 1/2, I can write the equation of this function. It is y equals 8 times 1/2 raised to the x power. And part B asks us to sketch a graph of that function. So now that I see what it is clearly, I'm going to go ahead and just plot these points. Right at 0, I get an 8. At 1, it gives me half of 8, or 4. At 2, it gives me half of the 4, which is 2. At 3, it gives me half of 2, which is 1. At 4, it gives me half of that, which is 1/2, and then 1/4, and then 1/8, etc. So, and because we're looking at this not in terms of a sequence, but we're looking at it as these functions, I would go ahead and draw this continuous curve, and I would be careful not to cross the x-axis, because this is clearly an asymptote. Which means it approaches x, the positive x-axis here, but it's not going to cross that threshold.